I'm glad you liked your beer.
Put my bedside.
So we've got one more day in section 2.5. Section 2.5 is on implicit differentiation. And as you probably know by now, hopefully by heart, implicit differentiation is what we use when you can't get the y isolated or the f of x or whatever. Right. Let's just do one example with some trig in it. So there's really nothing new here. No new concepts, just we haven't really seen one with trig, but the rules are still all the same. Trig's derivatives are still all the same. Good times. So we got 4 cosine x sine y equals 1. Guess what we need to do? Well, right, and that's actually a step ahead of what I was shooting for. Don't be. Guess what we're going to have to do? What's the next line? Yeah, differentiate it, so find, there you go, dy over dx. And in order to do that, we will indeed need to use product rule. And of course, since it's implicit, we'll have a little chain rule shout out going on too. All right. It's a product. I'm going to look at it as 4 cosine x is the first factor, and then sine y is the second factor. So when you use product rule, if you start with, yeah, you can go different ways. I like to start with this as is times that derivative, but when I come back the other way, I'll get what you said, something like that. We're going to start out with 4 cosine x times what? Derivative of sine angle becomes cosine angle. Yeah. We also have to chain on the derivative of that angle, which would be y prime. So the y prime is being multiplied by the cosine. It's not part of the angle. So I guess if I wanted to, I could maybe do that. You don't have to, but to make it clear, that's what I mean.
So you couldn't go like cosine y prime?
You could. It's just I want people to be clear that the y prime isn't part of the angle. It's separate. Alright. Plus, we've got to come back the other way on the product rule. So now let's start with the second thing. Let's start with the sine y. Times what?
-4 sine.
I like the -4. There you go. Yeah, the derivative of the first factor. So, for the sake of showing it, I'll put 4 here. Differentiating cosine angle gives you negative sine angle. So I suppose I could put the negative here, and then sine angle after it. We also need to differentiate the right-hand side. We get an equal 0. It's going to make things a lot easier in the long run. So 4 cosine x, cosine y, y prime. Plus, I guess we could call this -4 sine x, sine y. Now eventually we want to isolate y prime. So what would we do to get that done? What are we going to do before the division even? Yeah, okay, so let's add, this is really a negative term. So we'll add that over and divide away by all the extra stuff on this term. So y prime then would be 4 sine x sine y. That's what's getting added over. That'll form the top of our fraction. And divide away all the extra stuff on this term. Right? Yep.
Could you cancel the 4s and turn them into tangents?
Yeah, yeah. 4 over 4. And we can cancel. The reason we can cancel top to bottom is because everything here is connected through multiplication. It's one huge term. And everything down here is connected through multiplication. It's one huge term. If there were like a plus here, and you'd be done. All bets would be off. But since it's all just factored, you can cancel factors. You can't cancel terms. But yeah, Rachel's right. Sine x over cosine x is really just tangent x. And this would be what? Tangent y. One time my car broke down and some guy stopped to pick me up. No, well, I'm still here. So, but it was cold out, I was glad. And I asked him what his name was, and he said, he was from, I can't remember where he's from. It's hard to understand. It wasn't America, I know that. And he said his name was Tanny. And so when he picked me up and dropped me off, I said, thanks, Tanny. So we got assignment 19.
That was a good one.
That was beautiful.